Hello and welcome to Unit 8, Part 2. My name is Mr. Bell, and today we're going to solve some equations using the zero product property. Let's talk first about what the zero product property actually means, and then we'll see if we can apply it to some examples. What the zero product property means is if you're multiplying two things, whatever this is times whatever this is, if the product of the two factors is zero, that means one of my two factors must also be a zero, but I don't necessarily know which one. Let's just say this first factor on the left was 110. If the right factor was zero, 110 times zero is zero. So that makes my equation true. If the second factor was something like, I don't know, -4, well, the only thing that can multiply times -4 to give me a result of 0 is a 0. 0 times -4 is 0. So what we're going to do, we're going to use this concept to solve some equations using the zero product property. This slide says to solve the equations using the zero product property. Here we have the quantity x plus 2 times the quantity x minus 10, and the result, the product, is 0. So how can I apply the zero product property? Well, I don't know what these two factors actually equal. I don't know the exact value of x, but what I do know is that one of them, I don't know which one, but one of them has to be equal to 0 to give me a result of 0. So the way we solve this is I'm going to set up two equations. One where the first factor is equal to 0, and then one where the second factor is equal to 0. This will give me my two possible solutions. The first one, when we subtract 2 from both sides to solve it, we get a solution of -2. And the right one, when we add 10 to both sides, we get a solution of a +10. Now, let me try to show you how this works maybe in green. So if I plug back in -2 for x, this is what I get. I get -2 plus 2 for this one, and then -2 minus 10 for this one. And let's see if it actually equals 0. Well, this right factor in green says -2 minus 10, which makes a -12. But that doesn't matter because the one on the left here, this -2 plus 2 gives me a product of, or a sum, of 0, and 0 times -12 is 0. So that worked. Let's try the 10 now. If I plug in the 10 in place of the x in my original equation, I get 10 plus 2 for the left one, then 10 minus 10 for the right one. Let's see if this actually equals 0. Well, 10 plus 2 is 12, but this other factor, 10 minus 10, is 0. And 12 times 0 is 0. So this is how you can check and solve for solutions using the zero product property. Just set each factor equal to 0. All right, let's see if we can apply that to the one on the right. It's the quantity 2x plus 3 times 4x minus 1 equals 0. Since I know the product is 0, I'm able to set both of my factors equal to 0 to solve them. Now, instead of one-step equations like the previous example, these are going to be two-step equations. And you'll start recognizing a pattern. For this one, we'll subtract 3 to both sides as my first step, getting 2x equals -3. And then I'll divide by 2 as my last step, giving me one of my solutions is -3/2. And the other one, I'll add 1 to both sides to get 4x equals 1. Divide both sides by 4, giving me an x value of 1/4 in this case. After some practice, you're going to start noticing that the factors and the solutions are opposites of each other. If my factor was x plus 2, then my solution is a -2, which is the opposite of +2. If my factor was x minus 10, well, the solution has to be the opposite of this to give me 0 in that parentheses, which would be a +10. Same thing over here. The opposite of 2x plus 3, we would subtract the 3 from both sides and then divide by 2, giving me -3/2. And we would add 1 and then divide by 4 to get the 1/4 solution. So start paying attention to the pattern here and it'll make things easier for you down the road. These two examples ask you to solve by factoring. So let's refresh ourselves on factoring. On this particular one, we're looking for two factors here. We're looking for the factors of negative 18 that add to be a positive 3. So I'm looking for some combination of 3 and 6. To get a positive 3 as my sum, I'll have to put the negative with 3. So my factors here are x minus 3 and x plus 6. If I multiplied those out, it would give me a product of this. So it's been factored. Now that it's in factored form, we can find the solutions. And remember from the previous slide, one of these two factors has got to be 0 to give me the product of 0, hence the zero product property. And we're going to solve this one just using the pattern. This left factor, since it says x minus 3, well, the opposite of that would be that x is positive 3. And the other factor that says x plus 6, its solution or its root will be opposite of that, which is a negative 6. And just for example in yellow, the x plus 6, if you set it equal to 0, you would get the negative 6 by subtracting the 6 to both sides. I'm just skipping that step, trying to help you see the pattern. All right, now we're asked to solve by factoring the one on the right. This one has a coefficient a other than 1. So we need to do slide and divide here. We're going to take this 3, slide it over, giving me x squared minus 10x minus 24 equals 0. Now I need to factor this. I need to find some factors of negative 24 that add to be a negative 10. I'm pretty sure it's some combination of 2 and 12. But to get a sum of negative 10, I need to put the negative with the 12. Negative 12 times 2 is negative 24. Negative 12 plus 2 is negative 10. Let's put those factors in. That's an x plus 2 and an x minus 12. This is all review stuff from last chapter or previous chapters. We've done the divide. Now don't forget to go back. We've done the slide. Don't forget to go back and divide both of your factors by that same number that you slid. Given me this one on the left does not reduce, so it produces a factor of 3x plus 2. And the one on the right does reduce. Negative 12 divided by 3 is a negative 4 equals 0. Now let's see if we can find the actual solutions using the zero product property. This left factor, we need to set 3x plus 2 equal to 0. We'll subtract 2 to both sides, giving me 3x equals negative 2, and divide both sides by 3. One of your factors is negative 2/3. One of your solutions to this problem. And the other one's pretty easy to recognize. If my factor here is x minus 4, that means my solution is the opposite of that, which is a positive 4. All right, this was solving quadratics by factoring and using the zero product property. One last example to talk about on this topic. It says write a set of possible factors for the following solutions. Now remember from something I said on one of the previous slides, is there is a pattern, a relationship. The solutions are opposite of the factors, okay? So if I get a solution of x equals 5, what does that mean my factor must have been? Well, my factor should have been opposite of that. So my factor could be x minus 5. And let's see if we can do this another way down here in yellow. If x equals 5, and I want to try to figure out what the factor is, we would subtract 5 from both sides, leaving me with x minus 5 equals 0 on the right, and that is an example of what we've been doing on previous slides. This is my factor. Okay, let's take a look at the other example here. We want to write what the factor would be if my solution was 3/2. Okay, you may recognize from the pattern that it's going to be 2x minus 3 is a possible factor that would give me this as the solution. And in yellow down here at the bottom right, if that's confusing to you, if this was the solution they gave me and I want to find the factor, let's set it equal to 0. We'll cancel this divided by 2 by multiplying both sides by 2, leaving me with 2x equals 3. And we'll subtract 3 from both sides, giving me that 2x minus 3 so that I get 0 on the right side. There is the same factor that I came up with using the pattern. So the main idea of this part of the topic is that factors and the roots or the solutions are going to be opposites of each other. All right, Thank you for watching. Hope this helps.